Hello, and welcome to this video that talks about solving and graphing linear equations. So we start off by equation of a line. We need to be able to write equations in the form of y equals mx plus b when given a table, a graph, or a statement. So the normal familiar equation of a straight line that we all know is the y equals mx plus b. M represents the slope or the gradient, and b represents the y-intercept, which is basically where the line crosses the y-axis. The slope is a gradient, which is also delta y over delta x, and this is calculated by the following formula. B is the y-intercept. So let's take this example. As you can see, here's the straight line drawn on the graph. So in order to find the equation of this line, first we figure out the b from the graph, and this is where the straight line intercepts the y-axis, and that's a positive 2, so b is positive 2. And then we calculate m, which is the slope, using this rule. So let's take, now this rule is basically 2 points on the straight line taken at any point, and you just take the coordinates, the x and y of each point. So let's take 2 points and apply the rule. Let's take this point, for example. So the x coordinate for this point is 1, and the y coordinate is 5. And let's take this point, for example. The x-coordinate for this is 0, and the y-coordinate is 2. Applying this rule, we say that y2, so we label them to make things easier, y1, y2, x1, y1, and x2, y2. And now we just apply the rule, y2 minus y1, so 2 minus 5 divided by x2 minus x1, that's a 0 minus 1. And so we get 2 minus 5, that's a negative 3, divided by 0 minus 1, that's a negative 1. Negative cancels out, and then we're left with 3 over 1, which equals 3. So m, the slope for the line, is 3. Thus, the equation of the line is y equals 3x plus 2. So this is how we get the equation of the line when we have the graph. We simply see where the line intersects the y-axis, and this is the b, and we calculate the m using any point on the line. We take the coordinates and we apply the slope or gradient rule. Now, what if we're given just 2 points without any graphs? Same thing. We first label them to make things easier. And so, label each point. So for example, we have this point as A, this point is B. We label x1, y1, x2, y2, and you apply the rule to get the gradient, m. Now to get the b, you should use the m first, and then you use one of the points A and B, A or B, and you use their coordinates x and y. We'll see in a minute, but let's make sure that when we're given the points, we should figure out the slope or the gradient first. So we take those points, we subtract y2 minus y1, which is what we did here, negative 5 minus negative 3, divided by x2 minus x1, 2 minus negative 1. And so we calculate this and we'll get negative 2 over 3 is the gradient. And so now the equation is y equals mx, which is negative 2 over 3x plus b. Now in order to figure out b, you simply substitute in place of those x's and y's in this equation any x and y of one of those points. You can take any one you want. So let's take point b, for example. And so y here is negative 5 equals negative 2 over 3 times the x, which is 2, plus b. And now you calculate for b. So using your calculator, negative 5, and of course to solve for b, we multiply first the negative 2 over 3, negative 2 over 3, and this is multiplied by 2. And so you get negative 1.33 recurring, which is also negative, where's the mouse? You will get negative 4 over 3 plus b equals negative 5. Now to get b, you simply add this to the other side, since when we take one number from a side to another on the same equation, but to the other side of the equal sign, we switch the sign, and so this becomes a plus instead of a minus, and so negative 5 negative 5 plus 4 over 3. This will give us a negative 3.67, which is in the fraction form. B will give us negative 11 over 3. Thus, the equation of the line is y equals negative 2 over 3x minus 11 over 3. Now, you can simplify this equation instead of the fraction simply, by multiplying the whole equation by 3 to get rid of the denominator. So now you have a constant beside the y. So you get the point. I guess the mouse is not working anymore, but hopefully you got the point. Okay. So moving on. Okay, apparently we cannot move on. All right. Okay, moving on to the next slide, we have how about when we're given a linear equation and we're required to graph this equation. So what we should do. So this is an equal sign. Okay, graphing linear equations. Graphing linear equations, we use the slope and the y-intercept of a line from an equation in the form of y equals mx plus b to graph the line on a coordinate plane. So we're given this example. How do we solve this step by step? It's very simple. So first, as we said, we use the slope and the y-intercept. So what's the slope here? M equals 2 over 3, right? And the y-intercept, or the b, is positive 1. So we know this for sure, right? And we could simply plot this right here, positive 1. And so find the slope and the y-intercept. We've already done that. So we graph the y-intercept 0, b, which is 0, 1. Use a table of values x and y to find other points on the line. Now this is simple and to the point. So now we have an idea of how the line should be, because we have the gradient. It looks positive, right? It's going upwards. Now this is the idea that I should have about the line. However, I am not sure if it's going to be downwards or upwards. So we need to check. And we do this by using a table of values. What is a table of values? You basically do a table of 4 columns. You place an x here and a y here, and you place any value of x you want, so you can calculate the y. So then you have basically points to plot, x1, y1, x1, y1, x1, y1, and so on. So let's say we have 0, any number you want. You want maybe 10, 12, 3, 0, negative 1. Whichever number you want, you can place that, and simply you substitute this value of x in the equation to get the y. And that is for each value, of course, separately. And so you get the x and you get the y, and simply you plot the lines and you plot the points, and then you draw a line through the points, and then you have your straight line graphed perfectly. So 0, 1, 2, let's say. 3 points are enough. Okay, so you simply substitute. So 2 over 3 times 0, let me show you how that's going to be. Is supposedly equal to y. So what is it going to be in this case? 2 over 3 times 0, anything times 0 is a 0, plus 1, that will give us a 1. And so when I have a 0 in the x-axis, I will have a 1 on the y-axis. Okay, next, if I have a 1, I substitute 2 over 3 times 1 instead of the x plus 1. So 2 over 3 times 1, that's a 2 over 3 plus 1. You calculate that using your calculator maybe, and you get 0.3 recurring, and so on. But we can put it simply in the fraction form, and you'll get 1 over 3. What about 2? So this is 1 over 3. What if we substitute 2 in place instead of x? And so we get 2 over 3 times 2 plus 1. This will give us, using your calculator, you will get negative 1.3 recurring. And in the fraction form, it's a negative 4 over 3. Now, in the decimal point, you actually know where you should place your point. Now, you can, if your graph is like mine, the units are just ones, not decimals, then you can make the points further. Make the table values, the numbers that you include, the values that you include, make them further apart so you won't get decimals like I got. But it's okay. We can deal with this too. So now we got here -4/3. Now we simply plot. So 0, 1, we already have this value. And ask yourself, why do I already have this value? If you're curious, this is because the y-intercept is a 0b coordinate. So when I have a point intersecting the y, the point at which the line will cross the y-axis, the x is always a 0. You can see this because if I'm here, the x is also 0. If I'm in the negative, the x is also 0, the x coordinate, while the y is going to be just the y value where I cross. So if I cross at 4, it's going to be 0. The x coordinate is going to be 0, 4. And if I cross at -3, the x coordinate is also, it's not accurate, but the x coordinate is also going to be 0 and -3. This means that whenever you cross the y-axis, the x is going to be a 0. So when I have x is 0, y is going to be the y value. When y is a 0, the x is going to be a value. I hope you got this very clearly. It's very easy. So now we got the points, we simply plot them. All right, 0, 1 is already plotted. 1 and 1/3, was that a positive? Yes. And we said that it might be 0.33 recurring, so let's say this is here. And then you have 2, when we're at 2, this is going to be -4/3, which is also -1, right? So we assume that the line is going downwards as we agreed before. So our gradient gave us the right prediction. All right. So we have slight errors in the points. However, the idea is 1. So we have 0.3, okay? 1, 0.3. Let's make them closer to each other so that when we connect the points, they seem closer to each other and they make sense. All right, straight line. Let's say that's going to be here. Maybe this is off a bit, but oh, you got the idea. Right. Well, this is a bit too far, but okay. I guess the graphing has some issues, but we get the point. Okay, moving on to the next concept. Now, this is also an idea that I just mentioned. So when I'm given a y, graphing horizontal and vertical lines. When I am given y equals 3, this means that the graph is going to intersect the y-axis. The line will intersect the y-axis, because just know that when you're given the subject, the variable that is a subject of the equation, this means that this is where the line should intersect. So the y, it should intersect the y. So for example, y equals 3. This means that the line will intersect the graph at 3 in the y-axis. And so this will result in a horizontal line. When I'm given x equals 2, I will cross the x-axis. I will intersect the x-axis, and I'm going to intersect it at 2, and I will get at the end a vertical line. So they're opposites of each other. When I intersect the y, it's going to be a horizontal line, rather than when a y-axis is a vertical line. However, the point is to intersect the y-axis, not to have a vertical line. So x equals 2, I intersect the x-axis at 2, and I get a vertical line. This is the point of graphing vertical and horizontal lines. What if we're given simple linear equations and we're told to solve this equation? Very easy and simple. So, as you can see in this example, when I'm told to solve an equation, this means that the variable, whatever the unknown variable that there is in that equation, I need to find it. So when I need to solve for a variable, I simply need to keep the variable alone by itself. I don't need anything beside it. No constant, no variable, no nothing. Need the variable alone. So this simple example right here, how can I solve for x? So first I need to get rid of this constant by subtracting 4 from each side of the equation. Keep in mind that anything you do on this side of the equation, you need to do it on the other side. Whenever I have an equal sign present in an equation, I always need to do what I do on the left side, I need to do it on the right side. Just like being fair to the bottom and the top, which is the numerator and the denominator. Whenever I multiply the numerator, I also should every single time multiply in the denominator. Same here for the equations. -4 minus 4 minus 4. So we end up with 3x equals 13 minus 4, which is a 9. Leave the x alone, always leave the variable alone, and this is by dividing by 3 in each side of the equation. And so we get x equals 9 over 3, which is 3. Simple, right? What about when we're given brackets? Whenever you see brackets, do not panic. It's very easy. Whenever I see brackets, the first thing I do is I expand. When solving for linear equations, I always expand. Why? Because I need the variable by itself. I cannot have the variable by itself when it's inside a bracket. So 3 times y plus 3 times 2, which is equal to 5 times y times 5 minus 6. All right. Keep the sign as it is. When you expand, keep this in mind. It's very important. Now that I have expanded, I simply take the variables on the side and leave the constant on a side. Variable, constant. So now I simply subtract and keep the variable on the side by itself. How? This is by dividing -2 here and there. So negative goes out with a negative. 36 divided by 2, that's an 18. So y equals 18. I have solved for y. Okay. Now, solving systems of equations by graphing. Solving systems of equations. What is a system of equations? Okay. Now, this means, we need to be able to write equations in slope-intercept form, which is y equals m slope x plus b, that's the intercept, in order to graph them and use the graphs to solve a system of equations. That was a mistake. So use the graph to solve. Now, 2 or more equations with the same set of variables is called a system of equations. System of equations is basically when you have 2 or more equations with the same variables x and y. Sometimes you only have x's, sometimes you only have y's, and sometimes you have both. For example, in the next example we're going to talk about. So in graphing the 2 equations on the same coordinate plane, the ordered pair for a point, which means x and y, the coordinates of the point of intersection, the point of intersection is the solution of the system. So when we sketch, which means when we sketch this line, we're going to have a point of intersection. And so this is the solution for the 2 equations, the x and the y. Okay, let's start. So now I have this equation I need to solve so that I can sketch it and the other equation. Like we mentioned before, first, let's take a look at this equation. We have a -3 is the b, where the y-intercept, that's more accurate, so -3. And then we said we'll do a set of values, x, y, and let's say we'll have 0, 1, 2, or not 2, -1. And same goes for the other equation, x, y. We put the same values since the number line is not that long. So we need short intervals between the points. Okay, so graph each equation the same y coordinate. This is what we'll do. So I have for the first line, -3 is the y-intercept, and obviously from the gradient, we have a slight idea that the line is going downwards since it is negative. So now we simply substitute the numbers. So we have x, if x is 0, -2 times 0 minus 3, so that's a -3. When x is 0, y is going to be -3. And when x is 1, -2 times 1, that's a -2, minus 3, that's a -5. While when I have -1, -2 times -1, that's a -2 times -1, that's a 2. And minus 3, that's a -1. Right? Am I right? -2 times -1. You really need to make sure you don't make any mistakes. So that's a negative times a negative, positive, so 2 minus 3, that's a -1, that's correct. So we can sketch the line, plot the points now, and then we can join them and graph the line. So 0, -3, we already have that. As we said, this is the intercept line. 1, -5, and -1, -1. Does that seem like a straight line? It does. Okay. Right, we need to make it as accurate as possible. Okay, cool. We just need to stretch it a bit more. That's a bit too far, but so we can check where the point of intersection will be between the two lines. Okay, the table values for the second equation, 2 times, okay, so the y-intercept is 5. You can see this from the b right here, plus 5. So 0, when x is 0, the y is going to be 5 without substituting. So when x is 1, y is going to be 2 times 1, that's a 2, plus 5, that's a 7. And when x is -1, so that is going to be -2 plus 5, that's a 3. Plot the points, 0, 5, 1, 7, well that's a bit far. Okay, let's say this is here. And then you have -1, 3. All right, let's draw a straight line and then we'll check the point of intersection. And the point of intersection, as we mentioned before, is where the solution is. All right, so now we got the point of intersection. Can you all see? This is the point of intersection. And what are the coordinates for the point of intersection? -2, 1. Is that correct? Am I sure of my solving? Well, if I'm not sure, I can check the ordered pair. How? To check, you replace the x and y that you got from the ordered pair, and you substitute those coordinates at that point in each equation. Sometimes one equation works. It should be true to both equations. So let's try that. They should be the same. They should give the same answer. So again. So x, y. We have the first equation. Let's use y equals -2x minus 3. Substitute the y, that's a 1, equals -2. It should be true. So right side should equal the left side. -1, -2 times -2 minus 3. That's a 4 minus 3, that's a 1. So 1 equals 1. Is that true? Yes, it's true. So it applied correctly to the first equation. I can try the second equation just to be double sure. Y equals 2x plus 5. So substitute 1 equals 2 times, that seems like a 2, but it's a 1. So 2 times -2 plus 5. So 1 is equal to -4 plus 5, that's a 1. So is it correct? So my answer should be correct. So the coordinates that I got for the answer for these systems of equation, the system of equation is correct. So the final answer should be -2 equals x and y is equal to 1. This is how you could do it, or in the coordinate form or pair form, -2, 1. And that's how you solve a system of equations by graphing. Well, what if I'm not trying to use a graph? I use 2 solving methods, and that's substitution and elimination. So solving systems of equations by substitution and elimination. Super easy. Let's take a look. Substitution. In substitution, you are given 2 equations with 2 variables in each equation, and they are similar in both. You number the equations. This is the first thing you do. Second thing you do, sometimes you're given the equation straight away, y equals 3 plus x plus 2, whatever. And sometimes you are given both variables on the same side. What you need to do is to take one of the equations and make a variable the subject. Usually, making y the subject is easier. Making y the subject is easier. Now you can use equation number 1 or equation number 2. But I suggest using 2 because it's easier since you don't have a constant, and so you don't really get lots of steps just to divide the 2, etc. So simply, you make the y subject. Let's make it a subject then. So now, when I make y the subject, I should get y equals, I keep y on this side. What should I do? I should take x away, and so y equals 3 plus x. This is for equation number 2. Now, using substitution means I'll take this equation and substitute it into the other equation, which is 1. Now, what do I substitute what into what exactly? I shall substitute y equals x plus 3 in 1 and solve for x, which means which means I will take y equals 3 plus x. So we are defining y. We are defining the variable y, which means I'll define the variable y in this equation using this definition. Thus, I'll have 3x, which is equation number 1, 3x plus 2 times y, and the definition for y using equation number 2 is 3 plus x equals 11. Now, how do I solve for x? First thing we do when we see a bracket is we expand. As you can see here, it's expanded already, so 3x plus 2 times x and 2 times 3, that'll be 2x plus 6 equals 11. What do I do now? Leave the variables on the side and the constants on the side. So 3x plus 2x, that's a 5x, and I take the 6 away, minus 6, so I get the constants on the other side. And so 11 minus 6, that's a 5. In order to leave x alone by itself as a variable, I divide by 5 on each side of the equation, and so x equals 1. Now that I've got x, I can substitute it into any equation 1 or 2, and both you'll get the same very answer for y. So now I need to find y. I substitute x in the easier equation, which the one that I changed the subject for, which is equation 2, and I can use this too, this form. So I can use both forms, and I'll get the same answer. So y equals 1 plus 3, y equals 4. Thus, the solution, a pair of, and so we get y equals 4. So the solution set for this system of equations is 1 for x equals 1 and y equals 4. There is another method to solve the system of equations, and this is when the variable in both equations, both variables have a constant beside them. So no variable can be made the subject this easily, like in the substitution method. Now, in the elimination method, you first look for variables that are opposite, which means variables that can cancel out each other. Can 3x cancel out 2x? No, it cannot. Can 4y cancel 5y, negative 5y? No. So what we should do is make one of those variables similar to the other. So we'll make things easy and we'll make the x variables the same so that we can cancel them out by each other. Elimination, canceling out. Canceling out variables. One of the variables so that you can solve for one and then substitute to solve for the other. We'll see in a bit. So now we multiply 2x by 3, not by 3x, but just 3. And to make 3x like 2x, we cannot do that. We'll take the common factor, which is 6. 6x. So we need to get 6x. This is by multiplying this equation by 3. As we said, we cannot only multiply this number or constant. We will multiply the whole equation, both sides, by 3. And here we will multiply by 2. Now, in order for them to cancel out, we need to get one of them to make them a negative. So we will put a negative next to the 3. We can also do it for the 2, but let's just do it for the 3. This is the step that's solved here. So multiply both equations by a value to get an opposite variable. Then you combine the equations. Combining the equations is by subtracting. So you can multiply by a negative, or you can simply subtract the equations from each other. It's the same thing. So whether I put the negative here or not, the important point is to cancel out a variable. So this is by subtracting. Even though I do not multiply by negative, you simply subtract. So in this case, I simply multiply by negative, then I'll subtract immediately. So I will add, since if I subtract both equations, I'll end up adding the 6x plus 6x. So I need to add in order for positive and negative will give me a negative. So in order for those to cancel out, 8 plus 15, that's a 23, and 12 plus 57, that's a 69. So I end up with 23y equals 69. To leave y alone, you divide by 23 on both sides of the equation, and so you get y equals 3. If I want to solve for x, in order to solve the system of equations, I simply take y and substitute it in one of the equations. So 3x plus 4 times the y that I have, which is 3, equals 6. And here it's solved already. So solving for x, you get 3x. You get 3x plus 12 equals 6, and leave x alone. You will subtract, and so you get negative 6. Divide by 3, divide by 3. So x equals to negative 2. And so the solution set for this system of equations is x equals negative 2, y equals 3. This is how you solve by elimination. So elimination is all about canceling out a variable. Canceling one variable. Substitution, there is no cancellation. You make one variable the subject in one of the equations, and you substitute this definition of this variable in the other equation. Simple, right? I hope you got everything. Last but not least, let's solve a couple of other examples real quick. So solve the system of equation by elimination. So we have here, it's very obvious and simpler than the one that we just solved. This is because 6a minus 3b equals 27. 2a minus 3b equals 11. This is because we can notice that there is a variable that's similar to the other, so we can cancel it out easily. However, you need to keep in mind how we can combine those two equations together. Is it by addition or subtraction? Now, if I add negative plus minus, what shall I get? So it's negative 3b plus minus 3b. So this should turn into a negative. And so I should not use addition. What if I use a negative? Then negative 3b minus negative 3b. All right, so this will turn into a positive. And so I shall use, so these can cancel out. Oh, so these can cancel out together. And so I can combine them easily now. So we subtract. So 6a minus 2a, we get 4a. And those two cancel out. And so 27 minus 11, that's a 16. A will equal divide by 4, and so A equals 4. I need to solve for B, and simply you take the other equation, one of the equations, and you substitute. So let's say I take 6a minus 3b equals 27. So 6 times the a that I got, which is 4, minus 3b equals 27, 24, negative 3b equals 27 minus 24, and 27 minus 24, that's a 3. Divide by negative 3, divide by negative 3, thus b equals negative 1. Here in this case, they used the other equation and they got the very same answer. So the set of solutions for this system of equations is 4, negative 1. So the system of equations by elimination, another one, and it's very clear that we can cancel out immediately. So 8x minus 8x, will this cancel out? Yes. So what do I need to do? Do I need to subtract in order to get them added? Or do I need to add in order for positive, negative, so they can cancel out? Of course, I need to add in order for them to cancel out. So you add the two equations, you get 7, y equals 38 plus 4, that's a 42. Divide by 7, y is equal to 6. And you substitute the y equals 6 in one of the equations, let's say this equation, which is easier. So you get negative 8x times 12, plus 12, sorry, equals 4. Minus 12 equals 12. Yeah, minus 12 equals negative 8x equals negative 8. Cancel out, and x is negative 1. Thus, the set of solutions for this is negative 1, 8. Simple, right? This is much simpler than the one that we solved before, but how about you practice a couple of questions about solving a system of equations? Very simple. And you have the answers here ready, but you need to show your work during your test. Keep in mind you can use substitution or elimination, depends on the type of variables that you're given in the set of equations. Well, I hope you learned a lot from this video, and I'll meet you in the next video. Thank you.